Okay, day 5 of our trig identities unit, and we're finally getting into some trig proofs. So, proving trigonometric identities. To prove an identity, we want to manipulate one side of the equation until we can turn it into the expression on the other side. That is, we want to find the missing steps that turn one side into the other. Now, a nice rule of thumb is we usually start on the, and I'm going to underline this, the more complicated looking side. Okay, so we're going to manipulate the more complicated looking side, often simplifying it to make it look the same as the expression on the other side of the equation. Okay, so some rules that we must follow, and then some guidelines that will help us with these proofs. Okay, so rules. We can substitute equivalent expressions. Okay, you have a formula sheet. If you haven't found that formula sheet, you will find it on my website. But the formula sheet has a number of different identities. You can substitute anything that is equivalent into one of your proofs, and you can go from there. We can do regular algebra, so we can factor, we can add like terms, but we can only do this on one side of the equation. And finally, you are not allowed to move anything across the equals sign. Okay, some guidelines here, steps, or I'll put in quotation mark guidelines. And we've talked about some of these things, and we've practiced some of these things. But it's a good idea to start by changing everything into sines and cosines. So tan x, cotan x, cosecant x, secant x, they can all be rewritten in terms of sine and cosine. Okay, eliminate complex fractions as we see them by multiplying by a common denominator. Okay, expand the complex fraction, never expand the portion that was not complex. If there's a binomial in the question, you can multiply by the conjugate and then replace with the Pythagorean identity. So for example, the conjugate of 1 minus sine x is 1 plus sine x, and if you were to multiply those things together, you're going to end up with 1 minus sine squared x. And replacing with the Pythagorean identity, this is equal to cos squared x. Okay, so that's multiplying by the conjugate. Expand the conjugates, never expand terms that are not conjugates. Okay, so let's dive into one of these. And the first thing that we will keep in mind is we want to work with the more complicated looking side. Okay, so the left-hand side to me here is a little bit more complicated. So from here, what I'm going to do is I'm going to rewrite everything in terms of sines and cosines. So we've got tan x times cosecant x. I'm going to rewrite tan x as sine x over cos x. Okay, and we're multiplying this by cosecant x, which I'll rewrite as 1 over sine x. Okay, these sine x's cancel each other out. We end up with 1 over cos x, and 1 over cos x is equal to secant x. And now we have manipulated the expression on the left-hand side of the equation such that it is the expression on the right-hand side of the equation. So we're done, and we indicate that by just saying something like this. LS, or left side, is equal to right side, and that's the end of our proof. Okay, moving on. So again, we will work with the more complicated looking side. That is the left-hand side here. And I'm going to start by rewriting everything in terms of sines and cosines. So secant x is 1 over cos x. And then we're subtracting sine x times tan x. I will rewrite tan x as sine x over cos x. And I'm going to just rewrite that sine x as a fraction by placing it over 1. Oops. Okay, so what we've got here now is 1 over cos x. And we can multiply those two terms. So sine x times sine x is sine squared x. And then 1 times cos x is cos x. Now we've got fractions with a common denominator, so we can combine the numerators, which gives us 1 minus sine squared x over cos x. And 1 minus sine squared is one of our Pythagorean identities. It's equal to cos squared x. So we have cos squared x over cos x, and which means we've got 2 cos x's in the numerator, 1 in the denominator. We can cancel 1 out. So we're just left with cos x. And now our left side is equal to our right side, and we're done with that proof. Okay, next one. So again, looking at the more complicated of the two sides. Now I would say these are both equally complicated. So let's just work with the right side just to prove that it doesn't matter which side we work with. So we've got 1 minus cos x over sine x. 1 minus cos x over sine x. And if we flip back to the first page, one of the guidelines is that if there's a binomial in the question, we can multiply by the conjugate and then replace with the Pythagorean identity. So what I'm going to do here, our binomial is 1 minus cos x. The conjugate is 1 plus cos x. So we have to multiply by 1 plus cos x over 1 plus cos x. The reason for that, again, is we're multiplying by 1. Essentially, it's 1. So we're not changing the value, we're just changing the form. So 1 minus cos x times 1 plus cos x is going to give us 1 minus cos squared x. Okay, so we can expand the conjugate, but we're not going to expand the portion that is not a conjugate. So our denominator here, I'm just going to leave this as the sine of x times 1 plus the cosine of x. Okay, so we're not expanding that out. Now our numerator, this is our Pythagorean identity. I can replace 1 minus cos squared with sine squared. And this is all over sine x times 1 plus cos x. Okay, and there's a sine x in the numerator and denominator that we can cancel. So we are left with sine x over 1 plus cos x. And so the left side is equal to the right side. And we are done with that proof. Okay, and flip the page. Again, the more complicated of the two sides, so we will work with this side. Let's start by replacing everything with sines and cosines. So cosecant, we're going to rewrite as 1 over sine x. And this is minus sine x. And then we've got cos squared x in the denominator. Okay, now in the process here we have created a complex fraction. So let's eliminate the fractions in the fraction by multiplying by a common denominator, and there's just the one. It is sine x. So we're going to multiply the top and the bottom of the complex fraction by sine x, and what we will end up with here is 1 over sine x times sine x is sine x over sine x, which is 1. So we'll have 1 minus sine x times sine x is sine squared x. And then we've got cos squared times sine. Okay, and in the numerator, this is a Pythagorean identity. We can replace 1 minus sine squared with cos squared. And this is over cos squared times sine. Those cos squareds cancel each other out, so we're left with 1 over sine. And 1 over sine is equal to cosecant x. And so our left side is equal to our right side. Alrighty, and the last one, more complicated looking side, is the left-hand side. So we've got sine x minus cos x over secant x minus cosecant x. So again, we will rewrite everything in terms of sines and cosines. So we've got, I'm going to leave some space purposely on the right-hand side here. We've got sine x minus cos x divided by, now secant is 1 over cos x, and cosecant is 1 over sine x. Okay, so we're here, and once again we've created a complex fraction. So we can get rid of the fractions in the fraction by multiplying by a common denominator. The common denominator here is going to be cos x sine x, so the product of the two denominators. Okay. So in the numerator, I'm just going to leave this as is. We have sine x minus cos x, and we're multiplying this by cos x and sine x. In the denominator, we have cos x sine x over cos x. Cos x's will cancel each other out, so we're left with sine x. Cos x sine x over sine x. The sine x's will cancel each other out, so we're just left with cos x. And now that and that cancel each other out, so we are left with cos x times sine x. Okay, so is that what the right-hand side of the equation is? No, the right-hand side of the equation is sine x over secant x. So we need to manipulate this a little bit. One of the things we can do with cos x is we could rewrite it as 1 over secant x. Okay, secant is cosine's reciprocal. So we can rewrite cos x as 1 over secant x, and we're multiplying this by sine x as a fraction is over 1. So we end up with sine x over secant x. And so the left side is equal to the right side. And that's it for today.